Hi, and welcome to today's edition of the Nest video blog. We're very excited today to have a special edition where we're going to interview Nest's Chief Technology Officer, Moshe Kranc. Moshe is a very interesting guy. He's held a number of positions in technology for the past 25 years, both here and in Israel, where he lives. So this interview today will be coming to you partly from here in America and partly from Jerusalem. Moshe has a background that's deep in many different types of technologies. He even has an Emmy for his technology work, which is an interesting combination. He will be talking to us today about artificial intelligence and machine learning, some machine learning applications, and how machine learning can apply in a digital operations world. So without further ado, let's talk to Moshe. Well, welcome, Moshe, and we're very excited to have you here today. Obviously, we're excited to talk about this topic of artificial intelligence and machine learning and all the good it's doing today in the IT spaces. I guess what I'd like to ask you first is this question that, is it real? I mean, I just said all the good it's doing. Is it really doing good? What kind of tangible benefits do businesses see by implementing machine learning and using artificial intelligence?
Well, okay. Thank you, Sean. So for a long time, AI was mostly hype. When I studied AI in college in the 70s, it couldn't do much, right? It was very cheap card tricks, basically. But it's come a long way in the past 10 years. And today we see a lot of applications where it's bringing tangible benefit. First of all, I would divide it into horizontal and vertical. Horizontally, right? In other words, things that apply to all companies. It's a big boost to digital operations, right? Whatever else you're doing, right? If you can put machine learning in the flow, then you can do things much smarter. For instance, let's say classification and assignment of incidents, right? You have a process flow. At some point, you need to decide what it all means and who's going to deal with it. And you could put in a machine learning algorithm there in order to make that decision, or looking at event data from machines to decide what to do next. Let's say in the IT world, predicting future hardware needs, right? Just as the start of a process of raising the right purchase requests. In contact center, and many companies have contact centers, machine learning today can provide chatbots to reduce the manpower needed, call intent prediction to kind of decide if this person's calling based on their previous activities, what are they probably going to do? Churn analysis, what's the chance they're going to be churning? In marketing, let's say personalized emails are appropriate. In sales, let's say to help salespeople as part of the CRM process, who's the next best customer to call and what's the next best offer to make to that customer? All those are, I would call, horizontal. Vertically, depending on your industry, let's say in medicine, you can use it to diagnose x-rays, medical scans. In manufacturing, you can do predictive maintenance. Let's say you can anticipate when something is going to fail before it fails, and thereby increase the lifetime of the products, the machinery that you have out there. In fintech, we see it used a lot for fraud detection. Food tech, I've seen there are companies that have robotic food pickers now, right? Little drones that can see the cherries and go and pick them much at the same pace as a human and much more carefully. So it's real, and we're seeing a lot of innovation there and a lot of real world benefit.
So what would you say are the challenges in implementing an AI-based solution? What are the things people have to think about ahead of time, and what challenges might they face?
It starts with the complexity of the data. You have to deal with very large volumes of training data in order to get any insights. The data comes in many formats. Some of it is ginormous, right? Some of it is coming in at an incredibly fast rate of gigabytes per second, supporting the machine learning development cycle. It's a different development cycle than what we're used to for classical software engineering. In software, you build your program so that it's bulletproof. No matter what data you throw at it, it needs to be able to survive and give the right answer. Machine learning isn't like that. Basically, based on the data, you decide what algorithm is most suited for it. But if and when over time the data changes, right, you may need a completely different algorithm. It's not just bulletproofing this one. You may need to go to a completely different algorithm. And those kinds of changes will happen to your data over time. So at the outs, once you've deployed, you're not done. You need to have a feedback loop back into the people who developed it, right? So, and then another issue is that in the development cycle, you need a lot of collaboration, right? As you're tinkering with these models, you need teams to work together, and they need to be able to share information about data sets that are cleansed and of good use, and also of models that are maybe beginning to show some signs of success and need to be looked at by other people. So if I just give some examples of the need to tune an algorithm, right? I recently developed just a toy project taking the quarterly report, the recording on YouTube of Alphabet, right, the Google parent company, turning it, the recording is taking out the soundtrack, turning it into text, and then doing sentiment analysis and word clouds and n-gram analysis to try to get a feel, do some quantitative analysis on the text. And what all these told me was that the overall sentiment was positive. But when you look at, I then use some tools that give you explainability, right? And what I found out was that the main reason that it thought that the text was positive was because of the word tension and the word tense. Now, why is that? Answer, because I was using training data from a different domain. I was using trainer data from a set of movie reviews, because I couldn't find training data on finance reviews, right? Yep. And it turns out that for a movie, tension is a good thing.
Yep.
For the financial market, not so much, right? So there's an example of how, you know, the kind of data that you feed an algorithm, you know, that determines, whether you have the right algorithm at all, right?
Yeah. Well, I'll give you another example of that. I think, one of the things that we've done for one of the retailers that we've worked with is in the customer service management area, right? And they were, their primary channel for customers for like serious interaction really was email. Not a great solution, but that's what they had in place. And so we wanted to deflect some of that and be able to use automation to answer the questions from frequently asked questions. So we built that for them and got a great deflection rate. I mean, it was very impressive when we started to look at the deflection rate. But over time, the issue is, that doesn't, the questions now that are most important and are the ones that we would typically want to vector toward automation changed because we automated away that kind of first level of low-hanging fruit. Now that's all automated away. And the questions that are making it through into the filter now are very different than the ones for which we developed fact answers for automation to be able to handle. So same kind of thing. What kind of frameworks and tools and solutions are available to help solve these kind of changes today?
Well, you find solutions that are platform and vendor specific. Let's say AWS, Amazon has SageMaker, Google Cloud Platform has their own. And the issue that we have with that is that it creates vendor lock-in, right? Another thing we find in these current solutions is that they do not handle the end-to-end that I described, that starts in development, then goes into a training stage, then goes into a production stage, and then goes into a feedback loop, right? So, you find solutions that cover one of those areas, but the end-to-end and also the monetization part of it, when it's in production, how do you monitor and monetize the usage of whatever service you put up there? So that end-to-end across all the stages, you don't see in what's out there. Another limitation we find is that they don't really help much with collaboration. There are tools like Jupyter that you can use, but how do I know what data sets my colleague has, my fellow data scientist is using? There's nothing in the Jupyter tool itself that helps me. Or let's say a model that my colleague has developed. that would be of interest, I have no way to find that, right? There's no place I can search in a catalog in order to find those. So that's another lack that we find. But we've done these kinds of projects for at least a half a dozen customers, and basically we found these lackings, and so to overcome them, we've basically created our own framework called Simplify, which integrates all of the existing tools into a framework that addresses a lot of those issues.
Well, okay, so let's talk about Simplify, right? You mentioned, I think, some of the limitations of existing platforms. How does Simplify help? What does Simplify do?
Well, as I mentioned, it's meant to be a framework that organizations use when they want to build strategic AI capabilities that are beyond what any individual off-the-shelf tool can offer. So basically, we've taken a kind of a overall, a universal approach where we've taken all of the existing toolkits that are popular and we've fit them into a framework and then filled in the holes in areas that we're missing to create the entire end-to-end stack. So that means that we're not competing with any of the large-scale, vendor-specific AI platforms like Azure ML or SageMaker or Google ML, right? But instead, we integrate any and all of those into our products. So the framework that we're talking about, right, basically seamlessly supports hardware that's on-prem if you have bought, from NVIDIA, let's say, hardware accelerators, as well as in cloud into a single integrated end-to-end workbench. It implements and encourages an iterative agile development methodology, which is something that NES has great expertise in. We've won awards for our distributed agile methodology with built-in quality checks based on experience we have with test automation across the entire AI lifecycle. Important component that we've added that we didn't find anywhere else is a unified ledger, a catalog, right? As I mentioned, what good is a tool that enables sharing if you can't find things? So we've added a catalog so you can, of all data and all models and all operations on the platform, so that makes data easily found and reused, right? Reusable, and also experiments and models found and reused. We've added on top of that end-to-end lineage and auditing, because explainability is a big issue in machine learning, right? If you're going to use it to make decisions that affect people, you have to be able to explain why you made that decision. And so lineage and auditing becomes very important. And also important to detect bias that may have snuck in towards, the people who are unfairly doing well today in the society. Machine learning will enable them to continue doing well because it's only based on the training data, and sometimes you want to break those biases, right? Mm-hmm. We've also added the ability to do monetization. We've added an API layer on top of the production side so that you can meter and do pricing and management and tracking. So what we have then is an end-to-end framework that we believe is unique in the market and enables machine learning projects to succeed. It kind of walks you through all of the steps and solves the gaps that we have found in such platforms. We've used it with great success in a number of projects. Just a couple of examples with a major telco for churn analysis in the contact center. We use this framework in order to develop and deploy the system successfully. And a completely different example, a medical equipment manufacturer, we did a project for them to do scanning of MRIs and analysis to help the clinician make the diagnosis. And there again, we successfully used that product. And we've also used it integrated with ServiceNow as part of an HR flow to make some predictions about turnover, people who's about to leave and what's the expected demand, so that we can trigger processes and keep the hiring ahead of the demand.
That's great. I mean, the one in there that intrigues me, because this is again another issue. We have a lot of customers who are retailers, and they all have customer service functions. And you mentioned the ability to understand that customer service flow and make some like retention estimates that says, this customer is likely to stay, that customer is likely to go based on a pattern of interaction we have with them. I think that's really something that is a game changer in the customer service management market. No?
Uh, Definitely. And it's just a matter of training data. And many of these organizations have lots of training data. The problem is that it's just sitting there inert and they're not getting any use
Yeah.
from it. Now,
Yeah.
I do have to pause and say, full disclosure, in many cases that data is dirty and it needs to be cleansed. So
Yeah.
the dirty secret of machine learning is that 70-80% of a project is spent cleansing the data.
I
It's
bet.
only in the last 20% that you get to use it. And our simplified framework also has tools to enable cleansing the data. And oddly enough, the data that you need to drive machine learning can be cleansed using tools based on machine
Machine
learning. It's
learning.
kind of
Nice.
a
Bootstrap.
right.
Yeah.
That's right. So you can use machine learning on the data in order to identify outlier values and to fill in missing values and to enrich the data, maybe with field data that isn't there based on zip code, so you can fill in the address, and to find duplicates and big data of the size that you need. You can't do that manually. There aren't enough people and eyeballs in the world to do it. So you need the help and that machine learning provides. And we've integrated some of those tools into Simplify as well.
Well, Moshe, thank you very much for your time today. I think this has been really exciting. Any other topics you wanted to bring up that we didn't cover? Anything else that's important to understand?
Well, I would just close by giving a plug for NES in this area. What's NES's added value here? Well, it starts with our deep expertise in agile distributed development. We know what development is supposed to look like. We've won awards for it, and now we are applying that to the machine learning development life cycle, and that's a important combination. And with that, just end-to-end skills, both in data science and in production deployment, right? Those two things don't always go together. We have that in a rare combination. We are vendor agnostic. If you are already stuck with a vendor, we can figure out how to work with that, but we certainly won't come in and propose an architecture that creates vendor lock-in. We can also help you evaluate the feasibility of an AI initiative. Many of the 85% of projects that fail should never have been undertaken in the first place because they were trying to get machine learning to do something that it's not yet capable of doing, right? I mean, the example I give is for automated driving. Today, I can take a photo of a stop sign, paste onto it pixels that are indiscernible to the human eye that make the algorithm see it not as a stop sign, but as speed limit 40 miles per hour.
Ooh.
Until we can solve that problem, right? You cannot have a fully automated car so long as it can be attacked that way, right?
Right.
Another flaw that we see is what's called the elephant in the room. If you have a room that looks like a room, machine learning can detect the different objects. Stick an elephant in the room, and the algorithm falls on its face. Suddenly, everything is misidentified because something is out of context. And in a driving example, I have seen an elephant on the side of the street in Jaipur, India. It happens sometimes, right?
Sure.
And so that's an example of a project that is a little misguided. It's a little to really trust automated driving entirely without a driver is something that's ahead of the curve. And so what we can do is help evaluate the feasibility of a machine learning initiative. And the last thing I would say is that NES is, you may not have heard of NES, but we are the long-term trusted partner of a lot of companies you have heard of. we are the best company you've never heard of. And we would be happy to become your long-term trusted partner.
So when we do this evaluation of a project, is that done like in an MVP process, right? Where basically we're going to say, hey, this is, we think this has merit, and here's what the MVP for that would be, and roughly how much that would cost, and how to put all that together. Is that the kind of thing?
Exactly. Just an example, right? We had an engineer who put together a proposal for an automated grading system for teachers for one of our customers in the educational space. And it's only when you do but it's only when you do the MVP that you discover that it's great for multiple choice, it's okay for essays, and for solving mathematical equations, don't even think about it, right? Where there's multiple ways to get to the answer, right? I mean, so an MVP is essential, right? You have to try it. You have to know enough to understand what technologies could be used to solve the problem, but then you have to try it and see whether it works. And the proof is in the pudding, and there are always surprises.
Is the solution good for the problem you're trying to solve?
That's right. That's right. Or is the problem even solvable?
Is it solvable with today's technology?
That's right.
Well, thank you, Moshe. Thank you very much for agreeing to do this. I much appreciate your help on that.
Thank you. Thank you for the initiative.
Okay, great.
Bye.
Okay, have a good day. So long.
Well, it was great to have Moshe come on board and give us the benefit of his insights into this topic. I hope you enjoyed it, and look for more of these interview-style vlogs coming over the next couple of weeks. Thank you very much. Have a great day.